When it comes to diamonds, you may think of a defect as a bad thing. You might be imagining an ugly speck in the middle of an otherwise clear and perfect gemstone. It may surprise you to know that defects can actually be a good thing. My name is Dr. Solveig Felton and I'm a senior lecturer in the School of Maths and Physics at Queen's University Belfast. My research has been centred around electron paramagnetic resonance and specifically how point defects in diamonds can change their properties. These point defects are very small, of the size of one or a couple of atoms, and they make up far less than 1% of the mass of a diamond. However, by changing a very small number of atoms in a diamond, we can change the way it looks, but also its conductive properties. The hardness of the diamond will remain, however. For example, if you replace just one of every 100,000 carbon atoms with a single nitrogen atom, then a diamond will be yellow. If you also remove one of the carbon atoms next to the nitrogen atom, you get a defect known as the nitrogen vacancy center, which will make the diamond go from being the usual clear colour to being bright pink. This point defect is currently being heavily researched as a potential qubit for quantum computing. If instead you substitute a carbon atom with a boron atom, the colour of the diamond turns blue. This also changes the electrical conductivity of the diamond so that it can be used as a semiconductor. Diamonds exist in nature in a host of different colours due to the presence of these point defects in them. However, what those particular defects are is still a subject of research. While boron can turn diamonds blue, most blue natural diamonds don't contain boron. Indeed, if you have a blue diamond with boron in it, it is almost certainly a man-made one. The effect of point defects on the colour of gemstones is not limited to diamond. Aluminium oxide in a form called corundum makes up many gems. If they contain chromium defects, they will be a red or pink in colour and the stone is called a ruby. Any other colour and the stone is classified as a sapphire. Diamonds can also change colour based on whether they are exposed to natural or UV light, providing even more colour variation. Another material that behaves in a similar way is silicon. In fact, silicon and diamonds have the same crystalline atomic structure, but diamonds are almost completely carbon and silicon is silicon. We can also change a small number of silicon atoms for phosphorus and boron, which then has implications for how conductive the silicon is. This is why silicon is so commonly used in chips for computers and smartphones. This type of research has helped us develop the technology we all use today and will help us to continue to make materials that will make further advances possible.